Thanks. So this talk is titled about AWS and numbers. And the reason I'm talking about this, I did my master's thesis, of which you can see the title right up there. So cost analysis of a data collection system for news recommendation. So the numbers will pretty much be billing units and AWS bills, and what to think about when you build stuff on AWS and how to avoid those nasty surprise bills when you have an amplifier of 50 because you didn't think of some rounding that does happen in some billing at some place. And yeah, a bit of background. So I did my master's thesis on analyzing the cost structure and how we did data collection system. And it's basically in two parts. First was evaluate serverless versus traditional dedicated server, and the second one was evaluate AWS versus other cloud providers, in fact Azure and Google Cloud Platform. And this is a bit about the data collection system itself. Short review, basically it takes in data, modifies it a little bit, writes it somewhere, writes it elsewhere. All the short gist of it. So we're gonna have the text used a little bit later. And here's also a quick overview of what the traffic looks like. This is just to give you some idea of in which context I did my research. So everything is in this context, pretty much. And also a little slide about how the system actually looks like. And these are actually the slides for my master's thesis presentation, so they're not that well organized. Apologies for that, but we get the best. So we have a data collection system, and we have used these tools to create the whole thing. It's built on top of AWS. In fact, API Gateway was used earlier, but was abandoned due to cost reasons, which will become apparent later. And the two comparisons are first serverless versus servers. So we examined API Gateway and Lambda and compared them to running an instance in EC2. And then the second part, we compared EC2, S3, DynamoDB, and Lambdas with their respective counterparts from the other cloud providers. And so in short, my talk, know your billing units. If you don't take away anything else from this, this is the message. Billing units are the most important thing. Know what you're paying for, know where all the rounding happens, exactly what features are available, and do they cost if you enable them, and all that kind of stuff. It's always really important to keep in the back of your head, so to avoid all those nasty pitfalls, and of course to be able to make the customer pay less for their services, which is always kind of nice. Customers usually like the fact if you tell them we can do this cheaper. So first off, EC2 versus API Gateway. This was, for our case, this was quite trivial because our specific use case is the endpoint for the data collection system. So we take in a lot of relatively small requests, and we also need some other functionality to process the request when you take them in, but we don't need all the fancy tools that API Gateway does offer us. So in short, API Gateway is horrendously expensive, use it like we did, which is why we abandoned it. But as a matter of fact, one running theme in all of these comparisons is, of course, developer time needs to be counted into something. So if you're doing something that's not massive, usually it doesn't matter that it's an order of magnitude more expensive to use a second tool if the costs are like $10 a month versus $100 a month, because 1 hour from us is generally $100 a month, or euros. So it's always good to keep in mind with these numbers that these are always relative, and if you stay small, then the saved initial investments may well be worth to run more expensive stuff. And also you need to maintain instances and take care of them and all that, and you need to deal with scaling in some form. And the next slide is why we changed away from API Gateway. We can all see that for our costs, it was a tad expensive, and that was not very good. And also we had a pretty large scale, so we were able to make the investments to build an actual, it's built in Scala and Play, an actual application that does the whole proxying for us, pretty much. We also then, because we chose to do it as an EC2 instance, or as a dedicated web server, we were also able to implement some other functionality there, which otherwise would have been needed, like an in-between Lambda or something else, something like that. But all in short, API Gateway is good. It gets you started fast, but it can get really expensive if you don't use it for the correct way, so to say. Next, we have the EC2 versus Lambda, which is the other part we evaluated. And well, the same trends, of course, it's serverless, which means initial investments are down, scaling happens automatically, it's all fun and nice. But with Lambdas, there's also a downside to all that, which is you pay for the whole time it runs, essentially, which can be a problem. In this slide, we can see that for our situation, it would be better to use a dedicated instance. However, this is dependent on very many factors. One of them is the average runtime for a Lambda at the point where I did my measurements was 17 seconds. So it did quite a lot of data crunching. And the average time it spent on networking was 40% of the running time. So if you do networking, you pay for the whole like computational cost of Lambda because it just charges you for however many seconds you run it, regardless of if you actually use those CPU cycles or not. So in other cases where you, for example, would only do compute-heavy things and not have a lot of I/O or stuff like that, probably the Lambda curve would be a bit lower and it would again be cheaper to run that. But here we can also see the other very important thing, the cost difference is not really big. Both are perfectly feasible. So if you stay in smaller ranges, then again, small difference in price is offset by the fact that you need to pay someone to actually implement the whole thing, and then return on investment happens in somewhere like 100 years and nobody's happy because it's expensive and all that. And then you also need to consider this in like your whole application design. For example, one of the reasons occasionally the Lambdas run a lot slower is the Lambdas write to DynamoDB is because when DynamoDB autoscales, it actually stalls all the requests for a while, and that again stalls the Lambdas, which would be quote-unquote free if you had a web server, but with the Lambdas you pay for the whole running time. So again, no, what's your actual application doing? What are you paying for? How could you utilize your resources better? And Lambdas are good if you do a lot of computation. For that, they're reasonably priced, but you pay for the full price even if you're waiting for some other thing. For example, if you're integrating into some legacy API somewhere that takes forever to return anything, then Lambdas are probably a really, really bad idea, because you're going to spend most of the time waiting for the request instead of doing the actual crunching. And then it's a lot better to use a dedicated instance. Also, if you need to connect to different services, a lot of them, it could be a good idea to use a dedicated service because Lambdas are stateless. So for every Lambda invocation, you uptake all of your network connections and all that, and you'll be paying for that as well. So a lot of I/O, probably dedicated web server, but small tasks which Lambda is meant for, Lambdas are actually a pretty good choice. But just know what Lambda is kind of meant for. And then we go onwards. We have blob storage, which is S3, or the equivalents. So the equivalents are S3, Azure Blob Storage, and Google Storage. And this is mainly here for the sake of completeness. I did quite an in-depth review of this, but as it turns out, they're all priced pretty much the same. They price you for the stuff that goes in, the stuff that sits there, and the stuff that you take out. So there's not much really to consider. A couple of important points are, of course, to consider, for example, moving data within AWS generally is free, and moving data out of like AWS costs money, and also moving data between regions can cost money, and having tables to even have access from different regions also costs money. So again, think about that. Like if you're only living in your nice AWS or Azure or Google Cloud Platform silo and all the data is moved in between there, then probably everything is nice. You don't need to think too much about this. But if you have, then again, some legacy system you need to integrate to or do some stuff like that, then you're going to pay for the volume of traffic that goes through. Ingress, though, is usually free, so moving data into all of these services is free. But then again, if you need to move stuff out, then it can cost you. Yeah. Data stored and read and write counts and all that. And here we can also see, or back to the old graph, we can see differences. And basically, there are no major differences. They have slight differences in which requests fall into which tiers, so how much do they cost. Because from my understanding, all the cloud providers try and differentiate themselves. So they try and have a bit of a different pricing model so they could say, in this situation, we're cheaper. The actual conclusion from my thesis was that Google Cloud Platform's storage option could be the cheapest because I think those write requests are a tad cheaper than the other ones. So if you have a small load and a lot of small writes, it would be the cheapest option. But in some general case, usually they're all pretty much equally priced. And if you can probably optimize things to some degree to like cater to the specific billing scheme of a specific service, which is also really important to consider when you design your applications. Like taking one implementation and from one cloud provider and shoving it to another cloud provider may not be feasible. Might be that they charge for entirely different things, and thus it gets really expensive really fast. And then container service, which is EC2 and all the equivalents, is also here mainly for completeness sakes. The more interesting bits come later. Yeah, not too much about those. Basically just check that your provider has everything they need. And here could be mentioned that there are alternatives nowadays to just having a dedicated server. For example, Fargate, AWS has rolled out. So you only pay for used CPU cycles and used memory. So they have started to diversify kind of how you can get billed by how you run things. But just be mindful that there are options and do your back of the envelope calculations and think about, is this reasonable and how much will this cost for our client and all that. Then next we have databases. So this is DynamoDB and the equivalents. So large scale, NoSQL databases. And these are, by default, pretty expensive. But they're also really good. They're great at what they do. You can have data accessible, indexed, and fast. So they are pretty nice pieces of software. But they are really expensive. Why they're really expensive is, of course, because availability and all that. And we're going to go through first a couple of graphs and then talk about the billing units. So we have one scenario. This is, I need to check my notes. This is a read and write ratio of 1:1. So you write once, read once. And the item size of what's written is 1 kilobyte. Here we have similar, where you have ratios again 1:1, but the item size is 4 kilobytes. So here we can again see if you go and optimize stuff differently, then prices go all over the board. Then we have another one. Here we have 1:1 and 64 kilobyte items. So here we can see suddenly Google Cloud Data Store is no longer the most expensive one by far, but suddenly the other one, which is at DynamoDB, is the more expensive one. And lastly, we have yet another example, which is a write ratio of 5:1. So you write 5 times more than you read. So you only read parts of the data and 1 kilobyte items. And here we get to the actual beauty of billing units. So both DynamoDB and the Azure equivalent charge by write or read units. One write unit in DynamoDB is per write unit, you can write an item of up to 1 kilobyte in size once a second. Versus the Google Cloud Data Store only charges based on volume and count, and they charge much more heavily based on volume than count. That's why Google Cloud Data Store becomes cheaper when you go to bigger item sizes, because it's more optimized to have a more flexible load, versus AWS is more optimized to having small loads. And here can also be mentioned that it's really good to know all of these limits. For example, the 1 kilobyte limit. Given that that exists and that the write and read units are the more expensive part of your application, the data storage in these is relatively cheap compared to how much it costs to actually get the stuff out of there. It's really important to know them because, for example, if you have just under 1 kilobyte and you increase the item size by 1 byte, suddenly you're billed for 2. And this is really good to know. We actually had an example of this at a customer where we had one table where we had our items, and we wanted to add something like 20 columns. There were 3 columns. We wanted to add 20 more. And of course, the question arises, is this going to be really expensive? Turns out not at all, because our 3 columns were 160 byte or so, and the whole thing would only become about 600 bytes. So we're still within that 1 kilobyte range. So we don't have to upscale our write capacity to be able to deal with that kind of load. But as mentioned previously, if you're really close to the limit and then you go over it by a really small amount, you are going to be charged for the whole second amount. So here you can get a lot of weird edge cases where you suddenly pay a lot more when you didn't expect to do that. Lastly, we have serverless computation, which I already covered a bit more previously. So the equivalence of Lambda is, of course, Azure Functions and Google Cloud Functions. And here, I don't have all that much. This is actually the best piece to have. So here we can see that, again, they are differentiating pricing, or Google is differentiating their pricing, because both in AWS and Azure, CPU power is linear to memory. So if you just buy more memory for the Lambda function, it also gets more power. And then you pay more per second because the billing unit is gigabyte seconds. So if you have a Lambda, which is 1 gigabyte of memory, and you run it for 1 second, you're paying 1 gigabyte second. But a Lambda with half a gigabyte of memory, you're only gonna be paid for half a gigabyte second if you run it for 1 second. So it's the amount of memory times seconds gives you gigabyte seconds. And it's also really good to know that that's actually the billing unit. Like that's what you're paying. You're not only paying flatly for how long the Lambda runs, you're also paying for how much memory it has. And this plays into the part I mentioned in previously. If you have, for example, 40% networking on a Lambda, then of course one could argue that it would be a lot better to run a slower Lambda, because then you'd be paying proportionally less for the networking time it actually spends idling. So Lambdas will run for longer, but the actual running time will only increase. The networking time won't increase, presumably, and that's why you could get it cheaper if you actually decided to run a slower Lambda. And there's also been some research suggesting that it actually the best idea is to run the fastest Lambda possible, because these are kind of like the AWS Lambda and memory scaling, or CPU and memory scaling is kind of a guideline, and it can go above or below that, kind of, maybe. And there's some papers suggesting that Lambdas actually can, on average, run a lot faster if you have a more powerful Lambda than a slower one. So that's also really good to know, like what is actually like possible. Again, what are your billing units, kind of. So it's worth researching these a little bit, or being aware that these are things to consider. And then, of course, with Google, you could allocate memory and CPU separately, so that might also be really useful in some scenarios. Yeah, that was actually one of the main gists, but in conclusion, this is from the master's thesis presentation. So in conclusion, basically, if you run serverless things, they might seem more expensive. They usually are, but then again, an investment cost comes in, and suddenly, if the project's only going to live for 3 years, which might be a really long time for a piece of software, then it might be a lot better to do it with serverless, because developer time is really expensive. And then as for the cloud providers, the whole thesis was, of course, to evaluate which cloud provider would be the best one to implement the data collection system on, and the answer is really boring. It depends, because with all these different billing schemes and everything, you could probably optimize it to run from a cost perspective well on any of the cloud providers. But then again, that's just a probably. But the one main conclusion the customer wanted is that AWS is a good alternative as well. They're all comparatively good. Because it's also a result just to know, is it reasonable what we're doing? You don't always have to come up with, oh, no, this is the cheapest or something like that. It's also just good to know, like, have we done like sanity check on this? Is this at all reasonable? Could we get an order of magnitude cheaper services elsewhere or stuff like that? So it's always good to just keep all the numbers in mind and like check up what's actually what the client is paying for, what are all the services and all that. And here can be mentioned with cloud providers, the one thing I noticed they bill very, very differently is additional features. So for S3 and the equivalents, having multi-regional tables, there the cost difference was much more significant than actually just storing data in one area. And also for DynamoDB, the backup costs varied quite a lot between cloud providers. So if you have a specific need, for example, to go global or to have backups of something or stuff like that, that's also really important things to take into consideration when you do your back of the envelope calculations. Because usually, or I at least just like look at the front numbers, okay, we have DynamoDB and it costs this much to write stuff and this much to have it there, fine. This is a reasonable alternative, but then, oh yeah, we need backups and we need this and we need that, and suddenly all of those features are really expensive, and then you end up paying for them as well because you're invested already and can't really afford to change. So always like do your checkups. What is it what you're paying for? What are the actual billing units? And all of them, not just the apparent one, but also all of the like follow-up units and all that. And we come back to the same thing, know your billing units. One last thing, or last pointer actually. Another thing we found out after we had decided to abandon API Gateway and go over to building our own web service was we found out that with using AWS Firehose, that was from a billing perspective the best thing to do, because our individual requests are up to a couple of 100 bytes or something, and Firehose rounds everything up to the nearest 5 kilobyte again. So there again, you need to know your billing units. If we would just straight up put 1 kilobyte or even fraction of a kilobyte units in, we would have a huge multiplier in cost for that particular part. So always know your billing units. Thanks. And questions? If anybody wants to read my thesis, there's actually a physical copy in Helsinki in the library, or else I can send it to you, if anybody's interested. It's not available online because the customer asked for that. The publication is going to be delayed for 1 year. And the thesis has all of those numbers and more graphs. Graphs are fun. There's a lot of numbers, really a lot of numbers in there.
Did you at all look at, doesn't AWS provide like a billing calculator sort of estimate shitty tool thing?
I did, and it's bad.
Yes, this was my point. Did you try it? Did it at all correspond at all with like what you actually found? Because I find it doesn't.
No. I tried looking at it, and I just, no.
Yeah.
No, it's really bad. Doesn't take into account all kinds of things. Yeah. And yeah, one thing I thought of is good to remember. With Lambdas, the minimum billing unit is actually 100 milliseconds, which is not that short. So again, one of those small tidbits you need to keep in mind. If your Lambdas only run for 50 milliseconds, then you're going to pay double, essentially. Always know your billing units. Any other questions remotely?
What about this? So you, as far as I understand, you have this specific knowledge yourself, right? Kind of like team have this specific knowledge of billing. How does you think it can be applicable to like customer projects? I mean, can you just approach some, I don't know, project and say, okay, this will cost like 10,000, like 1,000, right? Like, so you understand, right? Kind of how is it sellable in your opinion, such a knowledge to the project, customer project? Like billing-wise?
I mean, I wouldn't necessarily say this is sellable per se. This is something which is part of the project all in and of itself. Because the only thing I did was one specific case study, and I can go to the customer and give it to them and be like, hey, here we can optimize your cost, everything's fine and dandy. But on a more general level, it's more just the knowledge I have would say is most valuable just as a reminder to dig down deep on your billing units and do your back-of-the-envelope calculations, and remember to take into consideration all of those latent costs like backups or multi-regionality and all that. So I would say that's the more important part, is just know your billing units.
Yeah, thank you.
Other ones? Nope, that's thank you for me.
Thank you.